Coming up, we are going to be talking about fractions, and we're going to do one of two things. We are either going to rewrite our fraction as mixed numbers, or we are going to take a mixed number and turn it into an improper fraction. So you'll see what I'm talking about. So for number one, we have 5/3. Okay, so how would you rewrite 5/3 as a mixed number? Okay, so 5/3 as a mixed number. Again, you keep your slates down. We got our popsicle sticks up here to the side. Appreciate the hands, they're awesome, but we want to make sure that it's equal fight here. Abby, what you thinking back yonder? 1 and 2, excellent. How did Abby, someone go 1 and 2, how did we get 1 and 2/3? No. Yep, you see how many times 3 goes, or 5 goes into 3, switch that. We have it, or yes, you're right, sorry, 3 goes into 5. We have it once, okay, so that's our 1. And then how many is left over? 2. And we're still talking about thirds. Excellent. Alrighty. Your next one, number 2. We are taking a mixed fraction and turning it, or a mixed number and turning it into an improper fraction. So we've got 1 and 4/5. 1 and 4/5. What kind of trades are we taking here? Give it a second. It's okay. I got my stick. I appreciate the enthusiasm, but I got my stick. Tiger, you got a gander, a guess back there? I would also say it's 9/5. Anybody else? We got some agreements. Excellent. Someone want to? Max, would you like to explain how he got to 9?
Yeah. So basically, 1 is 5. So you just got 5. You got 4 left over. So 5 plus 4 is 9.
So Max multiplied his whole number by his denominator. He got 5. He added that to his numerator. He got 5 plus 4 is 9. 9 over our original denominator, 9/5. Excellent. All right, we'll do another one. We've got another improper fraction that we're going to turn into a mixed number. We've got 21/5. 21/5. What should trading it for? We're on an orange stick kind of day.
Dang it. That's going to be me. I'm a yellow stick.
Chloe, you got a guess back there? What you thinking? I was also thinking, and so was the book. The book was also thinking for 4 and 1/5. Somebody who did not get their stick would like to explain.
So I know that 5 can 4 times, but 5 times 4 is 20.
Mm-hmm. Excellent. So then it's like 5 can go into 21 4 times evenly. That'll get us to 20. There's still 1 left, so that's why we got our 4 whole number. There's still 1 left over. We're talking about this, so we have a 5th left. 4 and 1/5. Excellent. Alrighty, you can go ahead and erase your slates. Go ahead and put your markers, your slates, and erasers away. Pull your math journals back out. Which we also have it up here. I finally got that chart made, but it's also just nice for you to have it right in front of you. Okay. My question for you, and you're gonna kind of just chat with your partners. Yes, you may get your which you're just gonna chat with your partners. Your pod section. A city zoo has an orangutan that is 60 and a half inches tall, standing upright. City Zoo, which if we let's pretend we had one here, okay. The Columbia City Zoo has an orangutan, stands 60.5 inches, not feet, sorry, inches tall. Okay. Is the orangutan taller or shorter than a fifth grader? Be prepared to use this data to explain your answer. And I'll put a little sticky note that says the orangutan is 60.5 inches. 60.5.
Um, I think it's like the same. I think it's the same. So the orangutan is
Just let people chat and get to it. I'll write the numbers down.
16 and a half. Yeah. And is it the same height as us? Or is it taller? Or is it taller? No. Wait. Depends. I don't miss it like as a normal fifth grade. Exactly.
All right. What are we thinking, Tyson?
It's a little bit smaller because there are eight fifth graders on one side of the orangutan and seven on the other.
Okay, so it's kind of in the middle. We're a little split here. Not sure. Right.
More smaller.
But it's a little bit smaller. Okay, Mary, what you thinking?
Well, I would say it's small. It's like how I explained is it smaller than one fifth grader? Yes, it's smaller than tiny.
All right. So is it one fifth grader? Or are we talking about like a average of the fifth grade? I got you on my list. I mean, you gotta wait. Hands down. I got you on my list. Ashley.
Yeah, I would say it depends how tall of a fifth grader we're talking about.
Okay. All right.
That's like down the middle on our chart for our class.
So, like, are we talking of all the fifth graders in the world? Are we talking about, again, just us? We are talking about just us in this. Are we talking about one, like, specifically? Are we talking about Willow back there, right? We don't know. Okay, we need to have more data. Chloe, what you thinking?
Well, I just think that like our average for most of our fifth graders was 60, 61, and then 62. And so because it's right there, kind of in between both of them, the average is more on the taller side. So I think maybe also like shorter than.
Right. So, looking at how many do we have? Like, again, he's kind of this right. Not, I don't know if it's a male. We're gonna say him. Okay. But he's like kind of right here in the middle. Again, we've got more, a little bit more over here, a little less over here. So again, you guys are thinking a little bit smaller. I'm seeing the same consistent thought pattern behind it. So we're not just like, I don't know, I'm just guessing. Just random. You guys are thinking about it and thinking about how many X's are weight on each side. Love it. Senna.
Since the orangutan is in the middle and also the average, it kind of depends if like since there's tall people, there's also like average people. Then it kind of
Again, we're taller than a fifth grader. We've got 16 different heights for fifth graders here. We don't know. Okay. Again, I know you're starting to echo each other, but I'm gonna let you all finish off your thoughts. George, what were you thinking about?
I was kind of saying the same thing, but because it's not 5 inches, there's especially like the 61, 62, that's 3 X's on the top, and on the other side just has one. So I feel like 6 people would make sense because that kind of averages out from 16 people to 10, 11.
Yep. So again, looking at our data points here, we're not just randomly guessing. We're thinking it through. How many do we have that are going to be taller? How many are going to be not as tall? Okay. And then trying to figure out where he falls in the middle. But Mira.
I think it's like as tall as an average fifth grader.
Okay, so Mira's like, I'm thinking right about here. Like right about here. Maybe others have been smaller. Right about here. Okay, love it. Emmett, last but not least.
I was thinking he might not be as tall as the average fifth grader because there's only one fifth grader that's that height. Also, yeah, he's probably shorter because there's 8 on one side and only 6 on the other side.
All right, so again, we're counting, seeing that difference. Okay, love it. So we are going to go back to this graph here in terms of talking about the orangutan and how tall they are compared to some fifth graders. Some of you guys based it on measurements. Some of you guys, again, looked at the X's. All great strategies to use when we are trying to figure out data. So What again? Remind me, and if you can't remind me, I'll remind you. What are these X's on here? What do we call them? Oh, Pearson? Data points. Yes. Okay. These are data points. They are points of data. Crazy. Mind blowing. I know. Shocker. It's too early for you guys to get mind blown. It's okay. Over here stretching on it. Okay. So we're going to use all of our data points in order to make it easier to understand. So when we are answering a question like this, it might be easier to what this book likes to call it is even it out. Okay. We want to even out our answers. So let's say I got these cubes. I know they're tiny. Bear with me. I'll stack them sideways. So let's say we have a tower that's 5 cubes tall. Pretend this is standing. And then we have a tower and it's 3 cubes tall. Okay. So imagine that we had these 2 towers and we were measuring them as data points. All right. So what could we do to even out these towers here? We were comparing them as data points. They're not super easily to compare. How can we like level them out, George?
You could take 1 cube from the back cube, put it on top of the 3, and it'll be even, so it's 1/4.
Christ. Excellent. Tyson.
You could just take out 3 blocks and put it into the 5 one.
Okay, could put 3 all on top of the 5, but that removes an entire data point. So what do we have to do to make these even? Cut it in half. Then it's still 4 and 4. Chloe?
Well, I was going to say something to make them basically.
Yep. So putting them all together and then cutting it in half.
No, this is.
Oh, this take one, move it over. Senna?
Can you go up to 5?
Mm-hmm.
You can also from the end of the 5,
Mm-hmm.
get 1 there.
Mm-hmm. Right down here.
Mm-hmm.
Take it the other way. Excellent. So then instead of the top, you took it from the bottom. Then Ashley, yep.
Basically, you could just add all of them up, and then what? You don't have to put them there. Just like add them up like in the or something.
Okay.
And then just divide it in half.
All right, excellent. So Asher's like, so I've got my 5, I've got my 3. I can mentally add those 5, 3 is maybe 8. Cut in half because there's 2 data points. 4. Excellent. Okay, these are all strategies that the book proposed, and you guys all told them to me, and I didn't even have to give them to you. Excellent work. Let's say, and again, it just makes using data points when we have lots of them easier to understand. Okay, we can find that average. Okay. Let's say we had, and I'll put the blocks out, but you may not need the blocks. We have a tower that is 4 cubes. We have a tower that is 8 cubes. 1, 2, 3, 4, 5, 6, 7, 8. And a tower that is 9 cubes. How can we even these out? Or how can we make these easier to work with when I get all the blocks? Sorry, they're so tiny. 3, 4, 5, 7, 8. Okay. Think to yourselves for a moment. Talk with your partner, and then we'll chat. Talk with your partner, and then we'll chat. Oscar, feel free to join in either pod in front of you or behind you to have this conversation.
9, 8, 4. You could do 9 plus 4 and 13. 13 plus 8, 21. 17 is 14 here, but you can't really do that.
How many data points do we have?
3. Or, yeah, so you could do 7. It's hard to tell. There's 7 extra. 7 each stack.
All right. And again, If I pull your stick and you are not feeling comfortable, that is totally okay. You can say I need to phone a friend. Okay, and we'll phone a friend. Senna, what you thinking here? And again, we have a few different strategies. What you thinking?
So you can add them up.
Okay, we can. Are you doing it in your head?
Yeah.
Okay, so we're adding all of them up.
9 plus 8 plus what's the last one? Yeah, 4 equals 21. And so instead of doing groups, and then you can do 25 by 3%.
Excellent. So Senna said he added all these blocks up. We've got 4, 8, and 9. Okay, we have 3 groups total. 1, 2, 3, or 3 towers total. If you want to think about it that way. 21 blocks total divided by 3 towers. It's going to get us an average of about 7. Mm-hmm. About exactly. Ashley, what you thinking?
So we're just basically getting.
Yes. Which is why I wish they would use the word mean, but they don't. They say even out. So yes, when and especially just for going into 6th grade, you guys are going to hear the words mean and mode. You've talked about them before in 4th grade. Yes, no, maybe so. Yes, hopefully, please tell me yes. Okay, yes. But I think you guys talked
about it.
just a
I was like, minutes of it, and then we took a little test.
I was like, I know you briefly spoke about it. Okay, that is also what we're doing here. We're talking about we are finding that average. Okay, so we're going to add all our groups up. We divide by the total amount, and then we get our average. So yes, you're talking about mean instead of evening out, as they like to call it. Yes, Chloe. Please do.
And then I took one of the 9 and put it onto the receiver. And then I thought, well, they're not complete yet. Even enough to add them
together. So Chloe's like, they're not exactly even, but she was able to move them enough to get to a good point. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Last, certainly not least, we move that up here, and there's 7, 7, 7. So again, moving blocks, using our mental math, we have got different strategies to even out data sets to make them easier for us to understand. Is that making some sense of what we're doing, why we're trying to make it easier here?
Yes.
Yes. Okay. All right. So we did our towers. We are going to go back and yes, sir.
Are we supposed to work in our books?
No, you were just watching this. This is all happening. Hello, sunshine. We're in math. So go ahead and just get adjusted and be back with us. Okay, so let's talk back about your message, your math message that you had. If we have an orangutan that is 60.5 inches tall, standing, are they taller or shorter than your 5th grader? Okay. How can we make it easier to answer that now with what we've just done? Ashley.
We could find the mean for the classroom.
We can find our mean, our average. We can even out our data set from our classroom heights to see how that compares to our 60.5 inch tall orangutan. Yes?
Yes.
All right. Seems like a much easier question to answer now that we have some sort of method to get there instead of just like looking at 16 data points. Yes, sir, we are going to do it. Yes.
So,
1 second. Yep.
So we can add them up, but we already did that yesterday. And so we all know that the answer 970.
I love it.
So then 970 divided by 16.
Okay, so that is a good point. If we open up our math workbooks, sorry, things are falling on my tiny desk up here. Okay, if we look back here and we see our data, let me put these blocks back up. Excellent. Hold on. I want everybody to get a chance to do this math. Okay, so we said, oh, that was the other page. It is 207 is where the data is. 207, 206. We'll say that again, 207, 206. And number 5 is where it tells us what is the total combined height of all the students in your class. That is 970 inches. We have 16 total points in our data set. So again, we take our total, so that's 970 inches. And I'm even going to write my unit of measurement on there to keep everything right in my head so I know what I'm talking about. 970 inches divided by, we have 16 data points. That's how many total data points we have, which would get us
60
60 and 5/8. Can someone triple check that for me? I will also do that. You got it?
Yeah.
Cool. I'll also do one up here.
If the average is 60 and 5/8, then that means that's bigger than 60 and a half.
Yep, 60 and 5/8 is what I got as well. So we've got some options here. This book says we have some options when we're talking about fraction remainders here, or when we're talking about our fraction leftovers. Do we want to round or do we want to ignore it? Is our question. Do we want to round this 5/8 or do we want to ignore it? Mira. Maybe round. Why are you thinking rounding?
Because 5/8, 5 you go up.
Okay. Because you go 5/8 would go up, rounding up seems easy. Ashley?
But I think it depends on like what we're using like the chart with. Like if we're just doing it by like ones, then maybe we round up. But since we're going by halves, we can just round down to the nearest half.
So we're going by halves. We can round down to the nearest half, right? Plus you. We could round up. Here's what we can do both. Okay. When it comes to the average height, we are talking very much average. When we were measuring you to the nearest half inch, was that exactly exact like your measurement? No, because it was to the, unless you were exactly to the half inch or the exact inch. I'm sure some of you were at a 1/4 inch or 3/4 or something like that. Yes?
Yes.
So we were still estimating, we were still averaging when we got our initial measurements. So it's okay if we ignore it or if we round up because it's still an average. Does that make sense? That we can round, we can ignore it. This is an average. It's reasonable to do either.
Yes.
Okay, awesome. Cool beans. For the sake of this, it does say if we use a calculator to find this, which depending on what the problems are in the workbook, I might let you do that for the sake of timing, because you know the operations and how to do this, but also some practice without it. If you're using a calculator, can we enter on your not as on like TI-84 calculators that I have, that can you enter in 1/2?
Yes. Yes.
How are you going to enter, Tyson? 0.5. Okay. Which I remember George, I'm looking at George raising his Oscar yesterday. He's like, wait, how do I? He's like, oh, got it, 0.5. Okay, immediately. So if we are doing our math inside of the calculator, remember 0.5, percentages, fractions, all those things. Excellent. All right, let's see if we get to get you into, yay, the next page. 208 and 209.
I'm already doing it by hand. Is that okay?
Yep, you can totally do it by hand. All right, so we've got some emperor penguin heights. We've got some chimpanzee heights, and notice they are all in inches. We've got some red kangaroo heights. That's real fun. So you've got these line plots over here. We've got some questions over here. It says use the data number or the information. Use the data in the line plot on journal page 208 to find the typical height of an blank. And you get to pick the animal. you get to pick the animal. Okay, so you either get to pick emperor penguin heights, chimpanzee heights, or red kangaroo heights. If you would like to work with a partner, I will allow, but you need to be with someone who is happen. You have to pick your topic before you pair up, and they have to happen to be paired as the same topic. You're not going to be like, okay, I'm changing it now. So if you are doing emperor penguin heights, raise your hand. If you'd like to work with a partner, you can pair up with someone who has their hand raised right now. If you'd like to work independently, feel free to work independently. Excellent. Okay, if you are doing chimpanzee heights, give me one of these so that we can keep it separate. If you would like to work with a partner, keep your hand up doing this. If you'd like to work independently, put your hand down. Yes. All right, and red kangaroo heights. Double hands up. If you'd like to work with a partner, keep your double hands up and find someone. So I've got 4. So make 2 groups of 2. So Willow's over yonder. Yep, cool. Abby, Chloe. I was like, Willow's these. And then if you didn't have this handle, hopefully the process makes sense for the rest of it. So if you are working, just try to be quiet about it. 6 on 5. If you have finished, you can go on to 210 while you're eating your snack. That is practicing fraction multiplications. So if you are done with the 209, you need to go on to 210. Yes. Do you want me to do yours? Which one is yours? All right, I'm going to do the Emperor Penguin one. Which one were you? 58. So your number should be 1044 for your inches. You should have 21. Wait, we're talking about penguins? Chimpanzees? Chimpanzees. Okay. Chimpanzees. 1044 for your inches. Yeah. 18 chimpanzees. 18. All right, so I'm doing Emperor Penguins. Again, if you have not gotten your snack, please feel free to get it. Emperor Penguins. And yes, I have to say penguins to spell it accurately. Don't judge me. Don't judge it. Penguins. All right, and I'm going to add all of them up together. So I look over here, and yes, I'm going to use my phone as my calculator. I've got 41 plus, that'd be 41 and a half, plus 42, plus, oh wait, I don't have 42, minus 42, because I didn't have it. Okay, plus 43, plus 43, plus 46.5. I'm doing math up here, so plus 46.5. Skip to 47.5. There's 3 of them. Plus 48, plus 48, plus 48.5, plus 49, plus 49, plus 50.5, plus 51, plus 52, 52, 52, 52. That's why you guys have to be very, very careful when you are adding in 21 data points. That's 21 numbers that you have to add together. You have to be very careful about what you are typing in. Maybe you thought you pressed the 2 and the 1, maybe you accidentally just pressed the 1. So instead of adding 21, you just added 1. Okay, those tiny calculators stick. They are not easy to use. You have to be very careful when you are typing stuff in on those. Yes.
That's actually the answer I got for right kangaroo.
Okay, so again, we have to be careful when we are adding things together, especially 21 things. Even on a calculator, it can get messed up pretty fast. Even use that's why I'm saying doing it on paper, you have to be very clear in where you're going. If you're doing it on a calculator, you need to press enter each time because you guys can't do multiple operations on those calculators. Yes, Chloe?
Yeah, it's really hard to like do the number and then have to do 5. And I have to do my number and then 0.5.
Mm-hmm. Yep. So those things you have to redo. Did you notice how I kept my finger next to each X until I had pressed enter and then I moved on to the next one? That's how I keep track. I keep my finger next to the data point I'm adding. That's just a trick for me. All right, so 1,008 inches. Huh? Yep, and you can cross them out as you go too, if that helps you. Whatever you need to do to keep yourself in check. All right, how many data points are shown? Data points. What? How do I know what my data points are? Nolan. Thank you, Nolan, for raising your hand and reading the X's. All right, so I'm going to count my X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Thank you for telling me you're done. I appreciate it. All right, write a number model to show how to even out the data to find your typical height of your animal. So I am taking my total inches from all of the measurements, 1,008. And I am dividing it, because I'm finding the average over 21 things. I'm dividing it by 21, because that's how many points I have. Yes. Yep. Okay. And then I can show you that divided by 21, a nice even 48. And I can say inches, because we're talking about inches. So the typical height of a typical height of an emperor penguin is about 48 inches. Emperor penguin is taller or shorter than a typical fifth grader. Definitely shorter. Okay, typical fifth grader, I can even write over here for us. We said, what did we say? 60.5? We added up. 60 and 5/8. 60 and 5/8. Are we rounding up or down? Are we doing 61 or 60 and 5/8? 60 and a half. Okay. So 60 and a half. So we are even with that orangutan. Yes.
The typical height for a fifth grader is 60.65.
That was true. 60.625, which if we were going to round, we would round up on that one to 61. All right. But we'll stay with 16 and a half. Excellent. Yay. Oh, it told me to divide you guys into groups, but I let you pick. It worked out anyways. Since you're eating snack and we don't have recess, I'm going to go ahead and go over this next page. And if you're done with that, you can go into math boxes. For once, we can finally get through all the pages that they give us for a lesson. No, just because of how the lesson was set up. The only reason that we don't ever get to them is because their plans take longer. All right. Hannah bought a package of pencils. She took 2/3 of the pen to school. How many pens did Hannah take to school? This is multiplication, so we automatically know it's going to be multiplication. Chloe.
I know that there are like 3 times 4 equals 12.
Mm-hmm. Let's set up the number model first. What is our number model going to look like? And again, think of of as like a multiplication sign. So she took 2/3 of the pens. George, George, you got it.
Alright. I ate 12 times 2/3.
Okay. Are we doing 12 times 2/3? I guess either way it's synonymous. So yeah, fine. Yes. But the way they have it is 2/3 times 12. Okay. So we're gonna say 2/3 times 12 because we are saying 2/3. Stop, gentlemen. 2/3 of 12 pencils. Remember how that is? So 2/3 times 12. And then we could say equals P for pencils. So again, we can do this by multiplying our whole number by our numerator. 12 times 2 is 24. We divide, Chloe, I mean, you can tell me how you got it too, because you got something different. We divide our new number by our denominator. 24 divided by 3 is what, peeps? 8. And I took 8 pens to school. Chloe, how'd you get there?
Um, I basically did the same thing. I just knew that so when you have 12 and you have 2/3, I knew that 3 times like I think before 3 times 4 equals 12.
Mm-hmm.
So if I had two of the 3, that would equal to 8.
Excellent. It's a different way to think about it. Good work. Okay, Craig is walking to a grocery store that is 3/4 mile away. When he was a half of the way to the store, he ran into his friend Greg. How fun. Okay. How far had Craig walked when he saw Greg? Senna.
2/4.
Okay. Let's set up our number model first. Emmett, what you thinking? Okay. Patrick?
So it's 3/4 times 1/2, and then I got 3/8 as my answer.
Okay, I am gonna flop it just because of how it's phrasing a half of 3/4, right? So I'm just gonna flop the way it's set up, but yes. So 1/2 times 3/4. Again, the only reason that I'm flipping the way, because you're gonna get the same answer, right? The way that it's phrased is why I'm setting it up this way. He was 1/2 of the way to the store. That's 1/2 of 3/4 miles. So that is why we did it that way. And then proceed. What were you saying for your answer? 3/8. Because again, very simple. How do we multiply fractions that look like this? We just multiply them across. So 1 times 3 is 3. 2 times 4 is 8. 3/8. And now I'll underline 1/2 of the way, 3/4. Yeah.
For the 1/2, you could make it 2/4 and still multiply like that, but you have to multiply this.
Yeah. Because we're using it anyways. All right. Lamar is researching postage stamps from different years. What a fun project. One stamp measured 7/8 inch by 2/3 inch. What is the area of the stamp? What should my number model look like? Someone that I have not heard from. How do we find area? Here.
You multiply.
Mm-hmm.
So 7/8 multiplied by 2/3.
Excellent. 7/8 times 2/3. And we want A for area. And then again, super easy. We just multiply across 7/8, 2/3. 7 times 2, 14. 8 times 3, 24. 14 24ths. And yes, you could reduce that to 7/12. 14 24ths inches squared. He's probably living his best life finding the area of a stamp.
Okay, good.
Yeah, I get it. I was like, wait a second. I was like, ah ha ha. Get him, get him. All right. Phoebe's class. Oh, this is Crushy over there. Phoebe's class has filled 3/4 of a box with food donations. The class wants to collect 4 times as much by the end of the food drive. How many boxes does Phoebe's class want to fill? Asher.
Um, so the answer was 3, and I got that by doing 3/4 times 4.
Mhm.
That's the number one.
So, and again, the phrasing. The phrasing is where I'm getting on this.
Yes, 4 times 3.
Yep. 4 times 3/4 of the box. Yep.
But
So
it's
that's
still 3.
it's either way you write it. Yes, for the sake of if the for a test and they wanted you to have it in a certain order, just for the sake of knowing how language affects that. Just that's why I wanted to bring that. Okay. 4 times 3/4 equals what? Box food box donation. I don't know. So then again, 4 times 3 equals 12. 12 divided by our denominator of 4 gets us 3. Super, um, super duper. I'm gonna just give you a number model sentence that I have in this book. Matt, yes, is making a pizza with his family. I know, fun day. Making a pizza with his family. Um, they decide. See, they decide they want to cover half of the pizza. Ugh, yeah, we're changing that from green peppers to pepperoni. With pepperoni, if you don't like pepperoni, you can change it to whatever your heart desires. Okay, but they want to cover half the pizza with something. Okay, um, with that, if you want to put apples on there, go ahead. Okay, Nat ate 5/6 of the parts with pepperoni. So they've got half the pizza's got pepperoni on it. Of that half, only half of the yeah, they just want half of it covered. Yeah, yeah. And of that half, Matt eats 5/6 of those slices. He, he's like, no, we only get half pepperoni. I'm eating all of it. Okay, basically, well, not all of it, but basically. Okay, so he ate 5/6 of the parts of the pepperoni. How much of the whole pizza did Matt eat? Okay. How much of the whole pizza did Matt eat? And again, to find that answer, we multiply our numerator by our numerator, and our denominator by our denominator. Yep, I heard it real fast. Yeah. What you got, sir?
It would be 5/12.
5/12. 5 times 1 is 5. 6 times 2 is 12. 5/12. Excellent. Of the whole pizza. It is indeed. And you guys need Chromebooks if you are in Spanish.
Yeah, let's go. What have you guys even doing?